All right. So the topic that we have today is periodic table, right? I want everybody to make sure that you guys are right, making the notes right and then, okay? Both of you. Hmm? I will give time first. You would have to understand, and I'll give time you to for you to write.
Okay.
First, try to understand everything. Then, or if you are able to write like the definitions and everything, you when I'm writing, you can write it with me. All right. And when I'm trying to explain anything, then you can stop and just try understand first, and then you can make notes and everything. So the definitions you can just write them with me when I'm writing. All right. So we will start with the periodic table. Periodic table, when you talk about periodic table, that is unit 8 in your syllabus, right? This is unit 8 in your syllabus. Unit 8 in the syllabus generally. So when you talk about periodic table, what is periodic table? Is a of elements, list of elements arranged arranged in order of their they are arranged in order of their increasing proton number. Increasing proton number. Proton number. This proton number is also called as increasing proton atomic number, right? The one that is present at the bottom, or it could be anywhere. It is the lesser number. The lesser number, or you can say the smaller number. The smaller number, like sodium is 23 and 11. We're talking about this atomic number, right? So is a list of elements arranged in order of their increasing proton number. All right, this is the definition. If you look at it, if you look at uh, generally, if you look at the elements, they are arranged in an increasing proton number. If you go from left to right, you will observe that the number is increasing, right? So the periodic table, the periodic table is divided into, you can write here from increasing from left to right, right? The periodic table is divided into elements, is divided into periods, to groups and periods, right? So the groups are the vertical lines, right? Groups are the vertical lines. They are numbered from from 1 to 0. All right. In total, there are 8 groups. This is how they are numbered: 1, 2, 3, 4, 5, 6, 7, and 0. This is how they are numbered. All right. You understand? This is how they are generally numbered from 1 to 0. Is this clear? Are you guys following, Eileen? Are you guys able to write what I'm
Yes.
writing? The period is a list of
Yes.
elements arranged in order of their
Yes.
increasing proton number. So when you're going to be from left to right, increases this proton number, increases proton number, proton number, or you can say atomic number. This was the number of protons or electrons. All right. Increases from left to right. This is how they are arranged. The periodic table is divided into groups and periods. The groups basically are the vertical lines. They are the columns. All right. They are the columns, vertical lines. There are total 8 groups. All right. This zero is called eighth group as well. But generally, most of the time you're going to see this as zero as well. Okay, zero group. Do you understand?
Yes.
Then we have periods. Periods in total 7 periods. All right. They are the horizontal rows. Horizontal rows starting from, they are from left to right. Okay. They are numbered as 1 to 7. Right. So basically, when you're moving in period, when you're moving from left to right, you will see that each number is going to be increasing by 1. The number of proton in period increases by 1 for each next element. All right. What do we mean by that? We mean, if you look at boron, boron is in group, in third group. Boron is 5 and 11. Carbon is 6 and 12. Nitrogen is 14 and 7. So you see these numbers, we are going across the period, across the period, right? You understand?
Yes.
If you go in a period from left to right, you will see that each number increases by 1. You understand?
Yes.
Before this, basically there is lithium. Before there is lithium, and then there is barium, and then boron, and carbon, nitrogen, and all of that. So the number you are going to see, this is 3, this is 4, this is 5, 6, 7. This is how you're going from left to right across the period. This is the left, this is the right. You're going across the period. This is 1. You can say this is 1 period, but it stretches onwards. It goes on to oxygen, which is 6, fluorine, which is 8, and it goes on to neon, which is 9. You understand?
Yes, sir.
16. Fluorine, I think, was fluorine was 19. This is the atomic masses, and this is 20. We should not be considering these numbers. These numbers, they can be in order, they can be in different order. We are talking about the smaller numbers. These smaller numbers are the one by which the periodic table is arranged. You understand? These smaller numbers are the ones by which the periodic table is arranged. They are the proton numbers, the numbers of protons and electron in an atom or atomic number. By it is so in short, the periodic table is arranged according to the atomic number, right?
Yes.
Starting from the first one, if you move on vertically from left to right, you will see that there is a gradual increase in a number, one by one, consequently, one by one, one by one, one by one. And the smaller number, this number can appear somewhere on the top. You might come across a periodic table which says like this. So but what you have learned, what you are learning is that the atomic number is always down. No, this could be the other way around as well. Okay, so you have to see the smaller number. The smaller number is the proton or electron number, right? The atomic number. The bigger number is the atomic mass. We're not When we discuss periodic table, we are not concerned with this. We are concerned with the atomic number, because this is the number by which the periodic table is all arranged. Helene, is this clear?
Yes.
All right. So more in periodic table. We have something more to know about in the periods. Each number of period represents the number of shells the atom of element has. Let's say if something is in first period, if something is in the first period, it means it only has one shell. Example is hydrogen. Hydrogen is in first period. Hydrogen is in first period. So it only has one shell. You understand? It only has one shell. If you look at sodium, sodium is in the third period. So all third period electrons or third period atoms are going to be, all third period elements are going to be having only 3 shells in total. Like sodium is in the third period. Sodium is 23 and 11. So if you make the electronic configuration, you will see it is 2, 8, and 1. How many shells can you see? 1, 2, and 3. So this is the third period. Do you understand? Similarly, magnesium comes right after sodium. It is also in the third period. Do you get it? Sodium comes right after magnesium. It is in the third period, and sodium is 24. Magnesium is 24 and 12. 24 and 12. So how many? If you try to make the number of shells, electronic configuration for this is 2, 8, and 2. Again, 1, 2, 3. 3 shells. Right? 3 shells, third period. Each number of the period. So what are we trying to discuss is that each number of period represents the number of shells the atom of element has. If something is in the third period, it will have 3 shells in total. If something is in the second period, will have 2 shells in total. If something like sodium, magnesium are in the third period, they will have 3 shells in total. All right. I'll give you another example. If you look at potassium basically is in the fourth. Let's see. let's see calcium. Calcium is uh, 40 and 20. Can you draw the electronic configuration for this? Lean, can you tell? For calcium, 2 in the first maximum, then there are 8 in the second maximum, and then 8, how many is that? 8, 8, 16, and then 2, this is 18,
18.
and then 2, right?
Yes.
This is going to be the electronic configuration of calcium. So in which period is this calcium going to be? Can anybody tell? Lean, can you
Period
tell?
2.
Which period is it going to be in? Calcium.
Period 2.
No. Eileen, can you tell? Which period is calcium going to be in? Hmm? We've already discussed that
Third period.
the number of shells tell you the periods. The period, whatever the number of period is represented
Period
by
4.
the, yes, it's in the fourth period, right? It's in the fourth period. 1, 2, 3, 4. There are 4 shells. It means in the fourth period. Calcium is in the fourth period, and it's in the second group. We'll talk about groups later words. So is this understood? So the number of shells
Yes.
tells you the number of period it is in. So number of shells is same as period number, right? Let's move on. I'll give you time to write this, don't worry. Let's move on to groups. When we talk about groups, the group number, very important. This is something that is very important, okay? So group number, it could be 1, 2, 3, 4, 5, 6, 7, could be 8 or 0. It could be anything. So the group number represents what? Represents the number of valence electrons. It represents the number of valence electrons. The number of electrons that are there in its outermost shell. The electrons that are there in its outermost shell, or you can say electrons in outermost shell. If you look at sodium, I want you to understand this first, don't write it yet. It's 23 and 11, right? So if you make electronic configuration for sodium, yes, Eileen, what is going to be the electronic configuration for sodium? Can you tell? 2,
2, 8, and 1.
2, 8 and 1. Very good. 2, 8, 1, right? So whenever
Sir, किसकी configuration?
sodium is 11,
Okay.
right? Sodium is 11. It has
Yes.
11 protons and 11 electrons and 11 protons and 12 neutrons. So whenever we are making electronic configuration, we are going to be concerned with number of electrons. All right. So the electronic configuration of sodium ion is going to change from 2 8. That is it. This is the last one is going to go off because this one goes off. This one electron goes off when it is making an ion, right? So electronic configuration is always based on number of electrons, whether it is for ions, whether it is for an atom. So if you look at the last shell, this is the last shell, right? Last shell. So how many electrons are there in the last shell? One electron only. So it must be in group 1. Do you understand this, Alishba?
Yes.
Yes, sir.
All right. If another example, we can take oxygen. Oxygen is 16 and 8. What is going to be the electronic configuration for oxygen? Quickly, Eileen, which number are we going to be taking to make the electronic configuration of oxygen?
2 6.
2 and 6. Which one of these numbers did you take? This one or this one? Bigger one, the smaller one or the larger one?
क्या मतलब सर?
The smaller one.
By which one? By which number did you make this electronic configuration? By the bigger one or the smaller one? This one or this one?
Smaller one.
Smaller one. What is this number called?
8.
No. What is this number called? Is it atomic number, proton number, nucleon number, neutron number? What
It
is
is called atomic number.
atomic number? Right. Or what is the other name for this? Proton number.
Proton number.
So this is the electronic configuration. Now this electronic configuration is telling a lot about this element, right? And this atom particularly. What is it? It's in group. What is the group number?
Group 6.
Group 6. What is the period number?
Period 2.
Period 2. Very good. See, this is what you need to know. And the third and important distinction is the transition elements. All right, we will talk about that inshallah. So is this clear to you guys? Is there any confusion?
No, sir.
Alishba, you guys need to write this down, right? Since from where?
Sir, from the end.
All right. Alishba, I would want you to all right. You can write that down inshallah.